Hey everybody, what's up? I'm Ned Bellavance, nedinthecloud.com. Today, for 90 Days of DevOps, I'm going to be talking a little bit about the Terraform test framework and walking you through an example of how it might be implemented. But first, a little bit of background. Let's start with that. So, the idea of testing with Terraform has been with us for quite some time. Pretty much as long as people have been deploying infrastructure with Terraform, they've realized that there was a need to test it. And I'm going to dig into some of the different testing ideas and frameworks and whatnot in a bit. In terms of when the Terraform test framework was released, that came out in Terraform 1.6 and OpenTofu 1.6. So if you're using either of those, there is a Terraform test command now within Terraform directly, whereas before you would have used a third-party tool, something like TerraTest or Kitchen Terraform, to do your testing in terms of integration and unit testing. So let's start with a couple things. First, I just want to mention before I get into my stuff that if you have a moment, I highly encourage you to check out the blog posts by Matthias Fjellstrom. I think that's how you say his name. Sorry, Matthias, if I got the last name wrong. I'll include a link to his blog post. He's done some excellent work around the Terraform test framework, and I may have taken some inspiration from him, so thank you very much. And I also want to mention, a little self-promotion here, that I have my own YouTube channel, and it's Ned in the Cloud, where I do Terraform things on a pretty regular basis, like almost every Tuesday, if I can do it. So if you're interested in checking it out, link to the YouTube channel. Okay, so with that self-promotion out of the way, let's talk about the Terraform test framework. Now, hopefully, if you've been working in DevOps for a little bit, I don't need to convince you of the value of testing when it comes to software development. And let's face it, even though you might be an infrastructure engineer or a DevOps engineer, you're involved in the process of software development. And what you want to do is to be able to test your infrastructure's code as code, right? But infrastructure as code is a little bit different than traditional software testing. Terraform doesn't really have methods or functions for you to unit test. Typically, when you're writing code, you would create a method or a function in your code, and then you would write a series of tests to make sure that that method renders the output you're expecting when you give it valid input, and that when you give it invalid input, it throws an error in a predictable way. The methods, or rather functions, that exist in Terraform are baked into the binary. It's not something that you're responsible for testing. That's something that the folks who are developing Terraform are responsible for testing. So you're not really doing unit testing of a method or a function. And when it comes to deploying an individual resource, either it deployed the way you asked, or the API or provider's lying to you, because Terraform uses provider plugins. So if something's wrong about the way that a resource is being deployed because of the provider plugin, well, that's really a bug with the provider plugin and not necessarily something that you would be testing for. Although I still recommend testing to make sure that the resource you've deployed matches up to what you would expect from a functional perspective, because even if it is a bug with the plugin, you want to catch that before it ends up biting you in the butt. So if the API is broken or incorrect, that's not really a Terraform issue. You want to open up an issue with the relevant provider or the API itself or the Terraform core. If that's the problem, they have their own testing to run. So if you're not testing the configuration of an individual resource necessarily, and you're not testing methods or functions, what are you testing when it comes to infrastructure as code? And in my mind, there's like three categories of testing for Terraform. First, there's basic validity. Is my code syntactically correct, and does it parse logically? Now, Terraform isn't a compiled language, or HCL, I should say, that you define your Terraform configurations in. It's not a compiled language, so you're not testing to see if the code compiles, but Terraform, the core engine, should be able to parse it properly using the plugins and itself. You also want to make sure like the specified arguments that you put inside each resource actually exist, or that you've supplied the right data type for that argument. You want to make sure you've closed all your curly braces, or provided an argument value that's of the wrong resource attribute. You might have an argument in there that is referencing an attribute that just doesn't exist. So these are the sort of things that you want to test from a basic validity standpoint. We already have Terraform Validate, which does that. Terraform Validate will check and make sure you're syntactically correct and that some of the things that I just mentioned all line up. Then there's testing to make sure that the configuration renders the way you expect based on the given inputs. And that's really critical if you've added stuff like conditional logic or functions or validation into your code. If you receive bad input from the end user of your Terraform configurations, is it handled correctly? If you make a resource creation conditional, can you verify that that conditionality works the way you would expect it to? HashiCorp refers to this as unit testing, so I guess that works for me. We'll call that unit testing. And then the other category, the third category in this umbrella, is whether the deployed infrastructure works as expected, also known as integration testing. So let's say you're deploying a network with some complex routing and some firewall rules. Can you verify that it's configured correctly to pass good traffic and block the bad stuff? When you update a module that's used by a larger configuration, does everything in that larger configuration continue to function properly after you've updated that module? So you're testing the integration of resources that are in your configuration, whether they exist in the root module or if they exist in one of the child modules. Now, some of the checking that you would do can be handled by external monitoring tools. If I have a deployment and it deploys out something to my testing environment, I might have some existing monitoring tools that are making sure that the website endpoint comes up properly or something like that. But it's also nice to just have automated tests that run during code development to check functionality, and that can also run during the continuous integration process in my pipeline. So that brings us all the way back to the need for testing and what is the Terraform test framework. The Terraform test framework was created to answer the latter two questions. Does my code render properly, and do the created resources function as expected? For syntax and logic, you already have Terraform Validate, like I mentioned. But to do unit testing or integration testing, you would have previously needed to use a third-party tool like TerraTest or Kitchen Terraform. Now, both of those testing suites still absolutely work. And I would say if you've put a ton of time into either of those testing frameworks, I am not suggesting that you just abandon all that work for the built-in testing functionality from Terraform testing framework. The Terraform test framework is a way to declaratively express a series of tests to run against a given configuration. The framework itself uses HCL, just like the rest of Terraform. So on the bright side, you don't need to go and learn a different programming language like Go or Ruby. TerraTest uses Go, and Kitchen Terraform uses Ruby because it's based off of Chef Inspec. So if you don't know one of those languages already, but you've spent a lot of time writing Terraform HCL, then you're going to feel very comfortable because you're not changing languages and the way that you're expressing things. Okay, so let's get into how it actually works. Each test that you want to define uses a run action for running the test, and that executes either a Terraform plan or a Terraform apply. To verify the functionality of the configuration, each run that you have can have one or more assertions that check a condition and logs the result of that condition. If all the assertions in a run pass, the test passes. If any of the assertions fail, then the test fails. So we have our test being defined by a run and a different execution, whether it's a plan or an apply. You can specify additional information for each test run, things that you want to test for, like input variable values. I want to see what the run looks like if I specify these 4 or 5 input variables. You can also do things like define a provider configuration per test or for the entire test suite. You can even supply mock data for certain resources and data sources which is now supported by Terraform 1.7, and support is coming in the next version of OpenTofu. You can run all of the tests that you define for a configuration, or when you run the Terraform test command, you can select a subset based on the directory location or the file name. So let's check out the syntax for writing a basic test and running it. In Visual Studio Code, I have an example configuration open. And what this configuration does is deploy a static website to an Azure storage account. So it's creating an Azure resource group, and then it's creating a storage account where we're going to put our static website, and then a container to hold that website, and then finally a blob to put in that container, which will be our static website. So that's what this configuration does. Now let's talk about the syntax and the file naming for the tests. So within my directory, and let me kind of scoot this over a little bit. Within my directory, I have a folder called tests. And inside there, I have some subfolders and then also some file names that end in .tftest.hcl. So tests are defined in files with the extension of either tftest.hcl or tftest.json. And since I'm not a masochist, we're going to use the HCL syntax, but just know that you could define your tests in JSON instead if you really wanted to. Now, at a bare minimum, your test file will include a run block defining a test run. Let's take a look at the unit.tftest.hcl. So we have an initial block here, and it starts with a run keyword and then the name of the test that we're going to run. This one is called SA test for storage account test number 1. And then inside of the run block, you can specify which command for the test you want to use. Do you want to use plan or do you want to use apply? If you don't specify one, it will assume you want to run an apply test and not a plan. But for this one, we're just doing a plan. I also can supersede any variables that are defined elsewhere by defining a variables block inside of my run block. And inside there's the key value pair of the name of the input variable and then the value that you want to use for that input variable. So I have an input variable named website name, and I'm setting that equal to test website name. And then following that, I have an assertion. The assertion block is made up of a condition and then an error message. And I can have multiple assertion blocks within the same test. This one just has a single block. The condition of the assertion is checking something about the local.storage account name. So let's take a look at that real quick and see what's happening with that. Under the locals block in my configuration, I'm defining the storage account name and using some functions to transform the website name input variable. If you know a little bit about Azure storage accounts, you'll know that the name needs to be in all lowercase and cannot have any special characters in it. So what this transformation does is replace any non-alphanumeric characters with nothing. So it just removes all the non-alphanumeric characters. It adds on data 001 to the end of the name and then sets the whole thing to lowercase, ensuring that it meets the requirements for the storage account. So when we look at the unit test, what it's testing is given the input test website name with the capitalizations in it, will that render to test website name data with 3 digits after it, comparing that to the value that's stored in the local value storage account name. And so I'm using regex to do the matching. If regex finds a match, then it's successful, and then the can function says everything's good. If the regex doesn't find a value, then regex errors and the can fails and condition renders to false. So I'm basically testing to make sure that what I think I'm transforming with my text is actually working properly. And if it's not, then I'm sending back an error message saying this value that we used did not render properly. I got this value that's stored in local values and it doesn't match. So that's the first test. That's the basic test syntax. And let's see how you run it. So I'll bring up the terminal here. I'm already in the proper directory, and I'm simply going to run the command terraform test. If you don't provide it any arguments, it looks for a folder named tests, and then will run any tests it finds inside that folder that end in .tftest.hcl. And the test is already run. It was successful and ran very fast. The reason it's nice to use the plan command when you can is because a plan tends to run a lot faster than an apply. If you use the apply command within your run blocks, that means it has to provision the actual infrastructure before it will run the assertions against that infrastructure. Since everything we're doing for our first test is happening internally in the configuration, then the values are known after plan and we can successfully run the assertion. If one of the values was not known until after a resource was deployed, then we would have to switch this over to an apply test. Now that's just a single test. I have a few more tests in here, each of which is testing a different transformation of the value for the variable website name. And we don't have to look at all of these. I just know that they do run successfully. The last of these unit tests is a little bit different. It's still running a plan command, and it's still using a variable value for website name. But rather than having an assertion, we're saying that we're expecting a failure within our configuration. And this allows you to test different failure modes if you have validations inside your configuration. There's a few different ways to validate your Terraform code. You can validate it at the variable level with a validation block. You can do a precondition for a resource or data source, and you can do a post condition for a resource or a data source. And you can also add check blocks to your configuration. All of these are different ways to validate your configuration as it's deployed. If you want to test your validations, you have to be able to test successes and failures. Let's take a look at what's in my variables.tf for this configuration. In there, the website name input variable has a validation block. That validation block is checking to make sure that the length of website name is less than or equal to 17 characters. Because when you tack on the additional 7 characters from data 001, that hits the maximum of 24 characters, which is the limit for a storage account. So I want to make sure that I don't accidentally allow someone to specify a website name that is longer than 17 characters. I also want to test to make sure my validation works properly. So within the unit test, I'm going to specify a value for the website name that is over 17 characters, and then I will say that I expect a failure for the thing that has the validation block in it. In this case, var.websiteName is what has the validation block. So let's pull up the terminal again, and since I've uncommented these tests, I'll run a Terraform test, and now it's going to run all 4 of the tests that we've defined for the storage account. Okay. The tests have completed and all of them passed. Now, if I want to see what happens if one of the tests fails, I can just change the value that I'm specifying for the website name for the length test. And now my validation block is not going to fail. So no expected failure happens. And so that test will actually now fail because I was expecting a failure and it didn't happen. All right, my last test failed and it lets me know that the checkable object, we expected an error and we didn't get one, so that fails the test. That's exactly what we would expect. I'll undo my change so this test will now pass successfully. And now let's get into the integration testing portion of things, which is pretty interesting. My integration testing is in the integration test.tf test. And I commented it out earlier so it wouldn't run during the rest of the testing. Now we can actually go through it. Unit testing is focused on individual components in your configuration. Integration testing is focused on the configuration as a whole. Have you successfully deployed what you expected, and does it work as designed? For that reason, while unit tests are usually plan runs, integration tests are usually apply runs. That does mean they take longer to run, and they'll require actual resources to be created and then destroyed. There is a way around some of that with mock data, but that's really a topic for another time. And just like our unit tests, We are still using a run block to define tests. Now, let's think about what we would want to check. Well, we're deploying a static website. So I probably want to make sure that the site returns a 200 status code when I send a request to the URL. I could also check that the content matches what I expect or that I get a specific response from a certain path, but for now, we'll focus on the 200 status code. How can you use Terraform to access a URL and get a response? Well, the data source HTTP will do that for you, but we don't have an HTTP data source in our configuration that we can use to check. And we don't really need one as part of the configuration. It's not part of the config. It's part of our testing framework. So what we need to do is deploy the configuration and then run a test that spawns the HTTP data source and check the response. Now, here's probably a good point to mention how the Terraform test framework differs from typical Terraform code when it comes to modules and the order in which it fires. Unlike typical Terraform code, where the order of the blocks in your configuration don't really matter, the order of the run blocks in your Terraform tests does matter. Terraform is going to run these tests in order from top to bottom of your file. So for that reason, if you care about the order in which they fire, you probably want to put them in a specific order. Sometimes you need to set up things for your test that are outside of the configuration. So it includes a module argument where you can invoke modules that are stored locally or on the public registry, and then that becomes part of the state data that's accessible to the next run in your sequence of runs. With that in mind, in order to deploy this website and avoid clobbering an existing website, what I'd like to do is append a random number to the end of my website name. And so what I'm going to do is my very first test is not really a test. It's actually just creating that random integer to use to deploy the infrastructure. I'm sourcing it from a module, so the only argument that the module blocks takes is a source, and I'm pointing it at the tests/setup subdirectory. Now, if we look in that setup subdirectory, I have a very simple module here that uses the random integer resource to create a number between 101 and 999, and then pass that integer value out as an output. That output will be available to all the subsequent tests that are a part of the broader apply command. Going back to the integration tests, the next run in the series is execute, and this one is going to deploy the actual configuration. And so for this one, I just need to specify a value to use for the website name. I'm going to call it test and then get the integer from the previous run block. And the syntax for that is run.the name of the run, which is random int apply, and then the output I want to reference from that run, which was called integer. That's going to stand up the website, and then it's going to move on to the third run block here, which is check site, check that the website is up and running. So the command for this one is also apply. That's the implicit command anyway, but I thought I would show it explicitly as well. For the variables, I am going to need the website URL that I'm checking, and then I'm going to use the module that's stored in tests loader to create the data source to do the tests. If we look at the contents of that module, I'll expand loader and go into main.tf. It has an input variable called website URL, where we'll pass that website URL, and then it uses the data source HTTP to get the response from that URL. Going back to the integration testing, I'm passing it the proper value from the previous run. The homepage URL is an output of my configuration in the previous run, and passing that into the module. And then for the assertion, I'm checking to make sure that the status code of my data source equals 200. If it does, I don't get an error message. And if it doesn't, I do get an error message, and it tells me what the return status code is. So now that I've uncommented all of this, I'm going to run Terraform test again, and this time it's going to run all of the tests, including the integration tests. While we're watching this run, one of the things that initially confused me about the syntax for Terraform test, and this might confuse you a little bit too, is the fact that, first of all, the order of the runs matter. All of the runs that are of the same command type are going to run in the order that they appear. Even if they're in separate files, it's still going to run in the order they appear, and then it's going to run the files in the order that they appear lexicographically. So, for instance, that's why my integration test is going to run before my unit tests, because lexicographically, integration comes first. So that's what's happening there. The other thing that kind of confused me is the way that you reference the outputs of a module run in the next run. And so for that one, it's just important to remember the syntax is run dot the name of the run and dot the name of the output that you want to reference. If there's a value you want to reference, you have to set it up as an output. Within a given run block, if you want to grab a value from the module that's defined for that run block, you can do it directly as opposed to using an output reference, which is why in the assert condition, I can say data.http.main.statuscode, referring to a data source that's defined in the module tests/loader. So both of those things were initially a little confusing to me, but once I put it all together, I kind of understood the logic behind how it works. All right, all of the tests have passed, which means we have passed both our unit tests and our integration tests. That's pretty cool. The Terraform testing framework introduces a native built-in way to define tests that you want Terraform to run when you want to perform unit or integration testing of your Terraform code. You no longer need to learn a different programming language and write your tests there. However, it's still maturing as a technology and is by no means feature complete. So you may find some things that it doesn't do yet or doesn't do especially well that you would find a solved problem in another testing framework. I know that the group or the team in charge of the Terraform test framework is furiously working on updates, and they would like your input. So take Terraform test for a test drive, see what you think about it, and then provide that feedback to the good folks at HashiCorp and the maintainers of Terraform and OpenTofu, and you might get to see an improvement that you spearheaded. Okay, that's going to do it for my presentation for 90 Days of DevOps. Thank you so much, Michael Cade, for the opportunity to present. If you're looking for examples of the code, you can find them in the link down below, or you can also find them on my GitHub repository, Terraform Tuesdays. I'm Ned Bellavance, nedinthecloud.com, and I hope you enjoy the rest of 90 Days of DevOps. Bye now.